Tonight's lesson preview is going to be talking about the real number system. Before we start talking about the real number system, let's first do a quick mini review. So last week we started talking about opposites, and opposites are numbers that are opposite from each other on the number line and the same distance from zero. So numbers that are opposite from each other on the number line and the same distance from zero. So for instance, -3, +3. They are opposite to one another on the number line, and they are both the same distance from zero. -3 is 1, 2, 3 away from 0, and +3 is 1, 2, 3 away from 0. So the opposite of -7 would be +7. The opposite of +5 would be -5. Another word we learned last week was absolute value. That is going to be the distance away from 0. It is always positive. So the distance away from 0, and it is always positive. Okay, so we know that we're talking about absolute value when we see the bars that are around the number. So right here, we notice that -2 has bars next to it. So that's saying, what is the absolute value of -2? Or how far away from 0 is -2? We know that it is 1, 2 away from 0. And remember, distance is always positive. So the absolute value of -2 is 2. And the absolute value of 3 is going to be 3 because it is 3 away from 0. All right, so one last thing before I talk about the real number system. If you would like to go ahead and get a separate sheet of paper to write on, go ahead and pause the video because I'm going to do a concept check review for tomorrow. So go ahead and pause the video and get a separate sheet of paper to write on. All right, so tomorrow your concept check is going to be over absolute value. So let's go over some practice problems. So I have the absolute value of -16. So how far away from 0 is -16? We know that that is going to be +16. It is 16 units away from 0. Now if I have something that looks like this, 20 minus 5, and we want to know the absolute value. Well, first I need to solve that operation. 20 minus 5 is 15. So now I want to know what is the absolute value of 15, which would be 15, +15. All right, you might also see a problem similar to this. So the absolute value of -3 plus the absolute value of 2. Now, before you solve this, let's go ahead and find the absolute value. So the absolute value of -3 is 3. The absolute value of 2 is 2. So 3 plus 2 is 5. Now, you also might be comparing numbers on the concept check tomorrow. So you might see something like this. I might give you 6.5, the absolute value of 6.5, and I want you to compare that to the absolute value of -6.5. Well, I know that the absolute value of 6.5 is going to be 6.5, and the absolute value of -6.5 is also 6.5. So those are going to be equal to one another. Now, what if I threw in some fractions? Let's look at the absolute value of -1 and 5/8, and I want you to compare that to the absolute value of 1 and 2/4. Now, let's first find the absolute value. So the absolute value of -1 and 5/8 is going to be 1 and 5/8. The absolute value of 1 and 2/4 is 1 and 2/4. Now, when I compare these, I first need to have a common denominator. I can't compare them with this being an 8 and this being a 4, those denominators. Well, I know a common denominator would be 8, so I really don't need to do anything to this fraction, but I can multiply 4 by 2 and 2 by 2, and then I'll have 1 and 4/8. All right, so now which one is larger? Is it 1 and 5/8 or 1 and 4/8? Well, I really only need to look at the numerators, and I notice that the 5 is larger, so the alligator mouth is going to be open to 1 and 5/8. Now, the last thing that I'm going to talk about is I might give you something like this. 1, the absolute value of 5, 16, the absolute value of -20. And I want you to put those in order from least to greatest. All right, so before I do that, I'm going to find those absolute values. So the absolute value of -5 is 5. The absolute value of -20 is 20. So now let's go ahead and look at 1, 5, 16, and 20. Put them in order from least to greatest. So first is going to be 1. And then I notice that the absolute value of -5 is going to come second. And then we have 16. And then our largest is going to be the absolute value of -20. All right, now let's go ahead and talk about the real number system. So I'm going to first start off by defining some new vocabulary words. And actually, some of these you've already heard before. So whole numbers, we've heard of these before. That is going to be 0 and so on. So 0, 1, 2, 3, 4, 5, 6, and so on. It does not include negative numbers, fractions, or decimals. So just think, you can buy 1 whole pizza, 2 whole pizzas, 3 whole pizzas, and then also 0. But we're not going to include negative numbers, fractions, or decimals. All right, now we have integers, and we actually talked about this in class last week with our human number line. So that is any whole number and its opposite, plus 0. So for instance, 0, 1, 2, 3, and so on, but then also the opposites, -1, -2, -3, and so on. All right, and then also, this is new for us, rational numbers. This is a number that can be written as a fraction. So if you can write it as a fraction, then it is considered a rational number, and we'll talk more about that in just a second. And then real numbers. Nearly any number that you can think of. So this is going to include whole numbers, integers, and rational numbers. Okay, so all these new vocabulary words, whole numbers, integers, rational numbers, those are all going to be real numbers. Okay, so let's give some examples. I'm going to use this Venn diagram here, and let's start with a whole number. Okay, so let's use 5. I can order 5 whole pizzas, okay? Now, if you are a whole number, you are automatically also going to be an integer, and you're also going to automatically be a rational number. Now, we talked about a rational number being something that can be written as a fraction. Well, I can write 5 as a fraction as 5/1, so that can also be written as a fraction. Let's look at 0. We know that 0 is a whole number, If it's a whole number, it's automatically an integer, and it's automatically a rational number. All right, what if I give you -4? Well, -4 is not a whole number, but I do know it is an integer. Okay, if it is an integer, it automatically gets to be a rational number. So -4 over 1. Let's do another one, -15. Well, -15 is not a whole number, but -15 is an integer, automatically making it a rational number. So -15 over 1. Let's think about 3/4. That's a fraction. So I know it's not a whole number. I know that's not an integer, but it is a rational number because it's written as a fraction. So it's only going to be a rational number. And then what if I had 2/10 written as a decimal? I know that's not a whole number because I don't have a whole, and it's also not an integer, but it can be a rational number because I can write 2/10 as a fraction as 2/10. So if you notice, our rational numbers are going to look like fractions and they're going to look like decimals, okay? We're going to talk more about this in class, so think of any questions that you might have about the real number system.